Good afternoon, everybody, and welcome our presentation. We are dedsec, and the members for the team are Agustín Molinier, Alejandra Valenzuela, Manuel Rodriguez, and me, Elisa Piar. And we divide our presentation on 9 mainly points. Look, you can see in the slides. First of all, I'm gonna talk about the methodologies we adopted. The next, please. Recently successfully wrapped up Sprint 1, delivering our initial features, and we have just kicked off Sprint 2. To manage this complexity, we relied heavily on the Scrum framework, tailoring our team-specific needs. We execute all the core Scrum ceremonies to keep our development aligned and transparent. Our sprint planning helps us define a clear goals and commit to realistic tasks within our capacity. Instead of a strict daily meeting, we found a sweet spot with 3 dailies stand-up per week. This proved effective for staying in the same page and quickly addressing roadblocks without causing meeting fatigue. We also had backlog refinement section to ensure oncoming user story were clear, well estimated, and ready to be picked up.
Good. To continue with the development of the process of developing, we define two defined goals that we think that are the main purpose of at the moment of making a merge request that had to be taken in account. Before beginning with the developing process of issue or developing process issue story, we have to define the definition already that are most focused on have a clear understandable description, making sure that the person who will done it have clear what is the activity to do, a miserable acceptance criteria, always having facts that can be defined if it's completed or not, an accurate effort estimation that, like as Melissa said, is based on a sprint planning session, the identification of dependencies, having clear what are the tasks that we have to do before doing the next one that we have in our schedule. Then the defined test data, we have a clear goal about what is data is going to be tested in each case and what are the parameters that have to be taken into account. Finally, and prioritized and approved by the PO, who is in this case the tutor professor, who defined all the goals and all the requirements that we have to work with. Then we have the definition of done. To have clear that a issue has been completed and it's done well, we have some parameters that are, the first one is the code is implemented and tested. We define that we apply the phase of testing in another part, but the implementation of the code has been tested in a manual way and then with unit testing. In this case, we have clear that also there is no regression free. I mean, the code is regression free because if you implement the code in a way that you don't break the previous functionalities that were working good, your code makes sure that the development process is good. Documentation and scripts are all loaded. Everything is clear on the platform. Also, we are keen on ensuring a peer review participation by at least 2 members. We always talk between us whenever we upload a change, and we try to make our partners participate in our changes. And finally, the code has been merged into developer branch because we're following this structure.
Okay, in this section, I will explain the architectural decision records, also known as ADRs. ADRs are used to document important architecture decisions in a project. They help us understand why certain choices were made during the development process. They also provide long-term documentation, which is very useful for future maintenance. Another important benefit is that ADRs make it for new developers to understand the system and get on board faster. Finally, they help keep the team aligned since everyone can clearly see the decisions that have been made. In our project, we use ADRs to define key aspects such as the architecture, the technology stack, and the API design approach. In our project, we have 2 phases for the moment, where the phase one is only the transform legacy to API wet or API REST in with Springboot. We have more or less four ADRs when we can explain all the phase one, and the phase two we can more or less 3 or 4 ADRs. Okay, thank you.
Well, talking about requirements, the first requirements of the project were related to what the tutor professor have given us. And in this case, the main purpose was to build a RESTful user management API with a full CRUD and soft delete. The main purpose it was to implement a soft delete so that the user who will use our program are not exposed to a permanent deletion, what will make them not be available more. Also, we were given with a CLI system, and we have to ensure that we can share the database between the new API system and the legacy CLI system. Also connecting the database say relational, in this case, to focus on the idea of having the two environments working together, but immutability of them. Finally, for some mandatory authentication for secure API access, always implementing a JWT token every time we want to access to an endpoint that is protected. With that being said, we have defined 5 different user stories, and we defined that we were going to work with this user story because we consider them as atomic, as we can work with them. And the first one is focused on the authentication process, working with the login process. When the user logins, he receives a token that will allow him to continue participating into the app. Also, the register of the new users. Then we have the different queries to have information about the users. We have the query to add information about all the users or have information about the one specific user. Also, we have queries to date the information of each user. And finally, we can deactivate the records, as we said before, by a soft delete.
Okay, the next point is C4 diagram. With this, we have the system context diagram. This is the first level. And with this, we can understand how the system is interact with the external actors and system. In this case, we only have the user and the CLI system. With the CLI system, this is a command line application that allows the CRUD operations. Then we have the container diagram. This is the second level, and this shows the technology structure of the system. It represents the main containers that interact and communicate with the system. With this, we add the MySQL database that stores the user information. Then we have the components diagram. This level provides more detail inside a container, showing the internal components that make up the application. In this case, we have the user, then the Piccoli entry points that initiate the execution. Then we have the command handler, then the business logic, the data access layer, and finally the MySQL database. Next, please. And the fourth level and the UML diagram, we have this UML class diagram that represents the static structure and relationship of the YALA-U system, organized into 5 packages: commands, models, services, my bodies, and finally utils. In this case, we have many classes. For example, the user CLI that executes the user commands, the user command that has an association with delete user command, read user command, update user command, and create. All this has inherited with the command, and then we have some packages, for example, the services and my bodies that has an interface, and then the models and utils. In this case, we can say that the commands inherit a base command class and depend on the service layer to perform operation on users. MySQL DB service implements the user service interface and communicates with the database through user mapper. And then the user model is shared across layers, while string utils provides the reusable util support. Let's start with the 9 point is JIT. Obviously, agile planning must be backed by solid technical collaboration. Well, for version control, dedsec used JIT. Our workflow was straightforward but stricted. Nobody pushed directly to the main or developer branches. We maintain a specific naming convention. For example, initial surname / ticket number -- short description. One example could be mpiano / us1 - login endpoint. Every feature branch was delivered from our develop branch, which itself was based on main. To avoid messy measures commits and ensure a perfectly clean and linear history, we strictly use rebase to update our local feature branches against the developer branch. Once when the code was ready, we opened a merge request. We first assign the code review required at least on one peer approval, and every merge request description strictly referenced its associated issue ticket. For example, clauses / issue ticket. This rebase only fast-forward strategy prevents conflict and keeps our API stable through development.
Okay, and now we're going with the demo. So for the code structure, we follow a MVC pattern where obviously we don't have the view because it is an API, but we receive all the endpoints on the controller class. Here we have the two controller classes, the user controller and the login controller class. Now we're going to show you how it works with the help of the tool of Postman. In this case, we have the endpoints prepared. Now we're going to create a demo user, okay, where we pass all the attributes that we want it to have. When we send the post request in that endpoint, we receive the ID of the user. We are going to save it in a safe place to use it later. And now the next step is to log in. For this case, we have to change the endpoint, but not the verb, given the fact we are going to post, and we're going to conserve this data. When we want to log in with the account, what we're going to receive is a token. In this case, this token is generated via JWT. It is a JSON web token. We're going to save the token, and I'm going to show you where this token is generated. This token is generated with this class, where the claims are basically the login, and the secret code is this one. This one is in this case because we are just presenting it by an internal mode. In other cases, it shouldn't be written literally on the code because it's not sure. But just for the experience of this course, it's correct. This is the secret code, and it encodes the token. With this token, we need to use it whenever we want to accede to data modifications. In this case, the public endpoints doesn't require the token. That is what I'm going to show you, because now we're going to use the endpoint to get information about our user. We have to add the ID of the user that we have here now, and with and get verb, we can receive information about our user. Excuse me.
Also,
And now we're going to receive information. Well, here we have the ID, the name, the login, and the state of the user. And apart from that, we can receive also information about all our users with the verb get. And here we have information about all the registered users who were previously on the testing period. After that, we can update the information of our user using the ID of it, and replacing and using the give an idea of that, and using the verb put, because we want to do a modification. In this case, for example, it's not going to be demo user Hala, it's going to be demo Hala, and with send, we receive a forbidden status. Why? Because we haven't uploaded the token. Now we copy the token and we paste it, and with the authorization of the token, we can update the content. We receive a 204 code that is no content because it said us that we can load the info. Finally, we are going to delete the data of the user, just changing the verb and passing the ID. With this, also, we receive a 204 no content, what means that we successfully could delete the user. As you noted previously, we are not deleting the user because we just apply a soft delete on it, where we modify the status of it. If we search, excuse me, it wasn't the verb. If we search the user, we can denote that the state of the user is not appearing because it has been modified. If we also look for the user by itself, it's not appear because it was modified. Whenever we want to apply itself again in the database, we can modify the status of it. So that's the end of the demo with all the endpoints.
Well, to conclude, to wrap, we have successfully transitioned from a legacy CLI system to a modern RESTful API, be following Scrum ceremonies and maintain a strict Git workflow, like our revised strategy and mandatory peer reviews. We've ensured a high-quality, stable, and linear development history. With a solid architecture based on a C4 model and clear definition of done, we are ready to scale this user management system while keeping our code robust and well documented. Thank you for your time.